far the how far the uh, this dispersion is, for example, is too much, less. So one of the things to measure the dispersion is range, minimum and maximum. You have 100 observations. The minimum height is 3 feet, maximum height is 7 feet. So 3 feet to 7 feet is a range. So whenever you want to describe your data, you try to describe the range. And there is something like variance. So in case of variance, basically we'll be seeing that there is something like standard deviation, there's something like mean deviation, there's a mean, mode, median. Similarly, variance is there. If you do not take the root, right, then it will be the variance. In standard deviation, what we are talking about, we are taking the uh, root of mean of the deviation square divide variation square divided by n. There is a number of divisions, and then we're making a square of that. There is a something like divided by n or divided by n minus 1. There's a sometimes confusion. What do we do? So if you are 10 individuals and you are keeping party at one person's house, then 9 person needs to move. That means n minus 1, 10 minus 1. But in case that there is a large data set, 100 or 200 people are there, so subsetting n minus 1 doesn't make much sense. So we keep n. So whenever you want to find out standard deviation, at that time, you should remember that if data is more than 30, then you divide it by n, and data is less than 30, you divide by n minus 1. Whom to divide? That is the deviation square to find out standard deviation. So under the standard deviation, then the coefficient of variation. Now, see, this coefficient of variation is important because you can have certain kind of standard deviation could be too large, mean could be shorter, or mean could be too large, standard deviation could be shorter. So to find out this, that how far the standard deviation is there in terms, in relation with the mean, when you find out the ratio between the standard deviation and the mean, that will give you the coefficient of variation. We'll see the formula of each of that. Interquartile range. So 0 to 25%, 25 to 50%, 50%, 75%, 75 to 100%. So for interquartile range, we need to define two things, percent and percentile. Percent is how many people are having this characteristic. But when you use the word how many percent are below 2050, how many percent below 75, how many percent below 3%. At that time, when we demarcate that way, we use the word percentile. So this is about range, difference between largest and smallest observation. That will tell us, right? There's a range. At any given point of time, you can either write down your questions or you can ask in between also. You can raise hand, then talk about this. Then there's a simple thing, range. We are not going to too much detail. Now, standard deviation, right? Now, here you need to understand that why we are not using mean deviation and why we are going to use standard deviation. If the purpose of standard deviation is to remove the negative and positive, you can take absolute value also. Say if there's a minus 5, you take an absolute as a 5. One standard deviation, what we are doing is this minus 5, you square, make it a square and make it a 25. The reason is that in standard deviation, you go for that and you calculate. It is almost constant. Whenever data size is more, and if you go for mean plus minus 1 standard deviation, mean plus minus 2 standard deviation, the percentage is almost constant. While if you go for only mean deviation, it doesn't have that kind of consistency. That's why we are taking the standard deviation. And if you want to compare, let's say, two population, again, let's say Karnataka and Gujarat, we want to compare their height or we come their calorie intake, if we want to compare, then mean alone is not sufficient. So we compare mean and standard deviation both. And many other static operation, if you want to use, let's say t-test or other z-test, etc., most of the time you would require standard deviation. And I told you that standard error is also nothing but one kind of standard deviation. Square of SD is known as variance. That means if you take a, let's say, let me write down in a chat to make the thing easier. Suppose I have a value like this, 8, 10, 12, 14, 16, like this, or let's say even 15, 13, like this. I have this value. Now, when I find a mean out of this, let's consider that for time being, the 12 is a mean. So, 8 minus 12, then standard deviation is minus, not the difference, deviation is minus 4. Then 10 minus 12 minus 2 is the deviation. But when I take 14 minus 12, then 2 is the deviation. Now this to remove this minus 4 minus 2 sign, we make a square of it. So it's a 4 square, square of 4, then square of 2, like this. And once you make a square of it, make a total of each of them divided by n. Or if a figure is less than 30, like these are the figure, 7 figure. Out of the 7 figure, 1 will be near to the mean. So 7 minus 1 will do n minus 1. That will be known as the variance. But if we take a square root of this variance, it will be a standard deviation. Now, either you write a sigma or ST, it's okay. Now, this is a curve. Before we go to this curve, let me tell you that this standard deviation, you are measuring the distance between the two patients in the ward by 1 meter, 2 meter, like this. Or when you measure the weight of the person, you measure in terms of kg, or when you measure temperature in terms of centigrade or Fahrenheit. Similarly, in statistics, you measure the distance between an observation and mean in terms of standard deviation. Whether this mean is how far away from the observation, that is in terms of standard deviation. I repeat again, in statistics, we find out the distance between mean and observation in terms of standard deviation. Now, let me make it clear that whenever you take a sample, and suppose you are taking height in sample, we use the word variable. But when you want to same height, when you want to talk in terms of the population, the same height is known as parameter. The parameter is for the population and the word variable is for the sample. In statistics, most of the time to describe the population characteristics, we are taking a sample. So, in a sample, if you have a particular, let's say, the observation in terms of measurement observations, in that case, suppose we want to measure the hemoglobin level of whole Ahmedabad people. I have taken the sample of 1,000 people and I take a mean hemoglobin level of 1,000 Ahmedabadis And also I need to take standard deviation. Based on that, I'll be talking about the hemoglobin level of whole Ahmedabad people. At this time, when I want to talk about Ahmedabad based on the sample, if I take a large sample, my error will be less. If I take a small sample, error will be more. So, and same way, if my standard deviation is much higher, also the sampling error will be more. That means when I talk about the population, when I have a lot of standard deviation, more error will be there. So there is a relation between the sampling error versus standard deviation and the sample size. So sampling error depends on standard deviation and n. While finding out the lot of experiment, we found out the standard error is equal to standard deviation divided by root n. And when you want to standardize the sampling error, that is known as standard error, n, that will, based on that standard error, we'll be able to find out what will be the average hemoglobin of Ahmedabad people based on a sample. I will repeat this example so many times, so nothing to worry about it. But then standard deviation is basically a measurement, a unit, a standard unit in which statistics is using like the distance between observation and the mean. If this distance is more than 2 standard deviation away, then there's a likelihood that there is a significant difference between the mean and the observation. And when it exceeds the 2 standard deviation, we say that that is likely to be having some reason behind this, the event. Now, here is the concentration which is required from all of you, that you might have seen this standard normal distribution curve. Now, the what you should be using the word for time being till you understand it. This is a usual distribution curve. This is a usual distribution curve. If you take any kind of observation, forget this minus and plus for time being. But if you take any observation on x-axis, which is a measurement variable like height, weight, etc. Suppose you want to talk about height, and on y-axis there is a number of individual showing a particular height. I will repeat twice. While drawing this diagram, on y-axis it is a number of observation, while on x-axis it is a observation which is a measurable like height, weight, hemoglobin level, etc. Now, if I want to take height of 3 years old children, then in terms of when I take a centimeter, it could vary between 50 centimeter to let's say 100 centimeter. But then there's a likelihood that the child having 3 years age, as per the standard normal distribution curve, can have 1 centimeter height also and can have 1,000 centimeter height also, as per the standard normal distribution curve, because the definition says that there is a bilaterally, it's a symmetrical. It the line never touches, the curve line never touches the base, bilateral symmetrical, and it is a inverted U shape. These are the characteristics. So now, what you need to remember, you may not remember is 34%, but then minus 2 standard deviation to plus 2 standard deviation, this covers the 95% of observation. Suppose there are, let's say the mean is, in terms of, let me write in chat box so that let's say everybody is here or not. I give an example. Mean height of 3 years children is, let's say, 75 centimeter, and standard deviation is 5 centimeter. Now, there are 200 children. Now the question is, if for one child measuring 100 centimeter, now do you think this child is having this phenomenon of being 100 centimeter is occurring just by chance? That means there cannot be any reason, or do you think this is significant? See, the two words constantly come: significant or by chance. Significant or by chance. So, if it is significant, it is not by chance. If it is by chance, it is not significant. These four words will come often. By chance means it has occurred randomly, not occurred because of some reason. And if it is significant, that means some significant reason is behind that event. That is how we use the word significant and by chance. Now, this child having 100 centimeter height is by chance. It is a part of the group, and by chance it is 100 or that child has some kind of reason or some different thing. So, if you think this 100 centimeter is by chance, then write down by chance. If you think some significant reason, write down significant. So, write down by chance or significant. You can, if there's a problem in typing, one is by chance and two is significant. So give me answer. What do you think? The mean is 75 centimeter and the standard deviation is 5 centimeter. Standard deviation is 5 centimeter. Now you need to write down whether this 100 centimeter is a by chance or significant. At least some of you should write down, choose the one or two. One. Anyone else? If you give a wrong answer, 10 marks. If you right answer, 10 marks. But if you don't write anything, it's a 0 mark. Come up fast. I repeat my example. Child having 100 centimeter height in a group where mean is 75 centimeter and standard deviation is 5 centimeter. What do you think? One or two? One is by chance, two is significant. So let me tell you the distance, if it is more than two standard, now look at here carefully. This much distance, right? Plus minus two, so 95% people lie over here. So out of this 200 children, people between 75 plus minus 2 standard deviation, one standard deviation is 5. 2 standard is 10, right? So range becomes 65 to 85. 95% children will lie between this. That means 190 students will lie between the same 65 to 85. Now the question asked to you, the child having 100 centimeter, does it belong to 65 to 85? No, it's outside it. So child 100 centimeter is somewhere in 2.14% plus this 2.14, roughly say is 5%. So there is a chance that this child having 100 centimeter, less than 5% chance that belongs to the standard normal distribution curve in this particular example. In other way, 100 minus 75 is 25. Divided by 5, that means the child is having 5 standard deviation away from the mean. So if Z is equal to observation minus mean divided by standard deviation. So when you are measuring the distance between your chair and table, for example, or two chairs, if you in terms of the meter. So here we measure the distance between mean and observation in terms of standard deviation. In this case, z is equal to 5. That means z is more than 2. It is 2 standard deviation away from the mean, so least likely that it belongs to the curve. That means the by chance variation is up to 95%. Beyond that, we say it is significant. So the probability that it belongs to the group is less than 0.05. Other way, you can say the probability is less than 5% that it belongs to the group. Now here, everybody are requested to write down, or you just remember that P is the probability of event occurring by chance. I repeat, P is the probability of event occurring by chance. So if it is away, is too far away, is more than 2 standard deviation away, Z is more than 2, that means probability that it belongs to the normal curve, that it occurs by chance is less than 5%. In terms of percentage, it is 5%, so probability 0.05. Why? Because in a statistics, whatever we say that area under the curve is 1. In terms of percent, we say it is 100%. So when you say 34% is 0.34 is the probability. When you say 50%, 0.5 is the probability. In statistics, we use probability rather than the percentage. So P is a probability of event occurring by chance, which is less than 0.05. That means less than 5%. We call it as a significant because probability of occurring by chance is less. So probability occurring because of some reason is more. This is how you interpret standard normal distribution curve. I just would like to use chat again over here that my question is that out of 200 children, how many will lie between 75 to 80 centimeter? Tell me the answer if you have understood. How many children lie between 75 to 80 centimeter? Answer is there. You can see the mean plus 1. So mean is 75 plus 1 star is 80 centimeter. I am asking this area. This area is represented by 34.13%. For timing consider is the 34%. So 30%, 34% of 200 will be how many? You can calculate and write down over here. Quickly, at least one person should give the answer so that I can be sure that someone is listening to it. Wonderful. So 68%, 68 children lie between this. Similarly, if I tell you that how many children having 80 centimeter, 2 to 85 centimeter, what will be the answer? Anyone? I'm unfortunately everyone in the meeting. So 80 to 85. How many? 80 to 85. How many children? So it is 13.59, something like 14%. So 14% means 14% of 200 means 28, right? Good. So similarly, if you want to find out between 80 to 85 and 85 onward or 85 to 90 or 90 to 95, there is a Z table available. I have shared you the Z table. Sometimes we'll also know how to read the Z table. And not only this, you can also find out between 81 to 82 or let's say 91 and 89. All this you can find out. The Z table will give you the area under the curve. And based on that, you will be able to find out. So before I proceed to the next slide, anyone wants to ask any question? I'll wait just for a minute. 27 or 28 is okay. The both are doesn't, it's not too far. Any question? So we'll move further. Next slide. So
Sir, what is the answer for the first question you asked?
what was the first question?
Uh, the question you asked was that if someone has a height of about 100 centimeters, so it will be by chance or it will be by
So
significant.
let us find out Z. Z is equal to 100 minus 75 divided by 5, right? So 25 by 5 is equal to 5. So Z means 5 standard away. So if this is a 75 and 5 standard away, very least likely that that fellow belongs to the group. So it is a significantly higher, and there's a, it is not by chance. But
Okay.
if it is, let's say, exactly 85 centimeter, what do you do? 85 centimeter minus 75, that will be exactly 2. If Z is 2, what do you do? So our null hypothesis says that when you say the word null hypothesis, it only says that whatever is occurring in the world is occurring by chance. Even if a person having 3 years child having 1,000 centimeter height, null hypothesis will say that the 1,000 centimeter in the children group where it is a 75 centimeter is the mean, but this 1,000 centimeters there is no significant difference. Null hypothesis says that there is no significant difference. That is the, and the 1,000 centimeter also belong to this group. But then when we say that Z is equal to 1,000 minus 75 divided by 5, it's two less probabilities. The probability of null hypothesis being true is less than 0.000001, like that. So you reject the null hypothesis because it's least likely to be true. And you go for alternative hypothesis, and that is H1. Why there is a null hypothesis in statistics? Because we need to start somewhere. So we always stand that whatever is occurring in the world, that is occurring by chance. There is no significant reason behind. And then you prove or disprove your null hypothesis. If you prove it, you accept the null hypothesis and say there is no significant difference. But if you think that there is the least likely that null hypothesis is true, P is the probability of event occurring by chance, or you can say that P is the probability of null hypothesis being true. But when it is less than 0.05, you reject it. Nowadays, instead of looking at a p-value in advanced statistics, we don't look at the p-value, but we look at the range of the p-value. The how far the p-value ranges, even that range we sometimes find out, right? So, any other question? This is this was 100, but then I can't correct it. So this is a z is equal to 100 minus 75, and we need to fit it in the bracket and divided by 5. That will be 5. So z is 5, and that's why we say the p is less than 0.05. Actually, it will be less than 0.001. So any other question? Once you know this, most of the thing you will know. This is a, why I say 95%. Usually it is 95.45%. To make strategy simple, we consider 95%. for better understanding. This will cover 99%. If you take 3 is plus my standard deviation is 99.73. This is the area under the curve. Whether you are here or whether you are here, that shows area under the curve. And you should be concentrating at this level. This is a base in which context the observation vary, right? And the height shows the number of cases. So this number of cases and the range together makes the area. And area, total area under the curve is 100%, or in terms of probability is a 1. So if you remember that there is a, in statistics we are using 1%, if we use 100%, suppose there are 10,000 observation. So 10,000 observation we call it 100%. In statistics, even 10,000 observation we call it as a 1 unit. Now this method of finding out standard deviation, I am not going to detail because it's so simple. You are taking mean versus the observed value, mean observed value, mean observed value, make a square of it, make a total and divide by n minus 1. And observation is more than 30, you just take n rather than n minus 1. You should know the philosophy why n minus 1, because out of let's say 20, 30 observation, one observation will be almost near to the mean. And that's why that deviation will not be counted. If you count it, there will be error. Suppose there are only 5 observations, like 5, 10, 15, 20, 25. Now in this, if you go for mean, then 5, 10, 15, 20, and 25. 15 will be the mean. So 15 is not too at all away from the 15. So there are only 4 deviations. That's why n minus 1, 5 minus 1. So I repeat, if you have 5 observations, 5, 10, 15, 20, and 25, then one observation is the 15, which is almost near to the mean. So there is no deviation. If there is no deviation, why do we take a consideration it? And that's why to get a better result, we do n minus 1. This is example, right? This is a differences you find out. You find out the mean, right? And then make a square of it. And then you go for mean. This is formula of standard deviation. Now group data, you need not go for that. So I stop here, take another chart. This is pooled standard deviation you will come to have at a later date when you go for t-test, paired t-test and paired t-test like that. Now this coefficient variation, this you should mention in your study design or study also, because standard deviation, suppose in our case mean was 75 and standard deviation was 5 centimeters. Now instead of that, suppose standard deviation is 100 centimeters and mean is 110 centimeters. Then what will happen? Almost equal. If suppose standard is 1 and mean is 100, then it is very small standard deviation. So standard deviation, it means that coefficient of variation, if it is standard deviation more, that means more variation. If standard deviation is less, it is a less variation. So coefficient of variation in terms of the mean, that is important to show that your data is having less variation. You can see this example. 160 centimeter, 55 centimeter. This height is 160, standard deviation is 10. So it is 6.25%, right? While it is a 5 kg and 55 kg. Standard deviation is 9%. So you can say that the variation, coefficient of variation. So height variation is comparatively less rather than CV of the weight. So height is more consistent than the weight. Variation in height, coefficient of height is 6% and coefficient of weight is 9%. So this coefficient variation, you should probably, when you compare two groups, you should mention this. The quartile Q1, Q2, Q3, what is the distribution between Q1 and Q or Q2 and Q3? This is simple. Q1 is 25 percentile, Q3 is 75 percentile. And quartile deviation, Q3 minus Q1 divided by 2. Now, this shows that the distribution, if less than Q1 is too much, more than Q3 is too much, then this Q3 and Q1 distance will be less comparatively. Now, this you will require to find out whether the data is distributed consistently or not. Sometimes the person having too much weight, obese person have much more, or sometimes the malnutrition, undernutrition is much more. That can be found out. This is an example. The file is already shared to you. Right? So now, I'm summarizing the same thing. Now, when we say that, now I'm summarizing the thing. Just I will uh, share the screen. Now, when you want to compare, when you want to find out the, let's say about population, you want to find out the blood sugar, the mean blood sugar of more than 50 years old people, if you want to find out. When you take a first sample, second sample, when you go on taking multiple sample, more and more accurate you will be able to find out. That is the central tendency. More the experiment you do, you will be becoming much closer to the population mean. That is a central tendency. And for that, mean, mode, and median, all three, if we find out, that will give the better result. So we should have mean, mode, median, as well as a range, and also standard deviation to describe the population fully. Mean is a simple statistical and average, right? So this is something about mean, right? And about the mean is very simple, sum of the data divided by total number. Total number by as a mean. So this will be very easy for you to understand. Now the mean is a simple arithmetic mean, while median, for that you need to find out percentile. Less than 50%, more than 50%, that what is the middle. Middle value is the median. Middle value is the median. Middle value of ordered sequence, right? But then if there are two middle values, you take an average and that will give you the middle value, that is a median. So mean will be affected by the extreme values, while median will not be get affected by the extreme values because the middle value. While the mode is most frequently occurring value. This is a simple one, so I'm skipping very fast. There are two middle values, so it is divided by two, and that will give you the median. And mode. Mode is the most frequently occurring value. Here, the most frequently occurring value is 4.9. So that is the mode. And sometimes we say bimodal distribution. It is occurring in children as well as occurring in case of old age. So we call it a bimodal distribution. Unimodal, only one mode, there is unimodal distribution. So now I'm at the end of this lecture. At least you should know about the p-value, that is the probability of event occurring by chance. You should also know that mean is arithmetic mean, summation and divided by total numbers. Mean deviation, that is the deviations, and find out divide by n minus 1. And if you want to have a standard deviation, then take the mean of the deviation square divided by n minus 1. That will give you standard deviation. And then mode is most frequently occurring value and median is middle value. So this is the thing. But if you want to remember only one thing, you should remember that P is a probability of event occurring by chance. And that is if it exceeds, let's say P is more than 0.05, we say that we accept the null hypothesis, yes, it could be by chance. But if P is less than 0.05, we say that not by chance. There has to be some reason. So now the forum is open for question answer. And I have not touched upon the EPINFO now, but the next time I will start with some data set, particularly Oswego, and will find out on that day the how do we find out a range, mean, mode, median with the AP info. And then we'll be going for a next further standard error of mean, standard error of proportion, standard of difference in two means, standard of difference in two proportion. All this thing will be taking in a next session. So questions are, you can ask me questions right now. Anyone? So let me do some rapid survey. So you have grasped how much in terms of percentage, 10% or 30%, something like this, or 90%. For quick feedback, tell me this so that I know that how many of you are attending the session over of 1 hour, and all this will be available to you on online. Anyone else? So this Vijay Venugopal, I would like to understand what 40% you could not understand, right? So that kind of discussion should go on in the group. So average p-value, please explain again. Yeah. Anyone else? Okay, this is the right time to talk about p-value again. Yeah, that is a good thing. So it will take not more than 5-10 minutes. So suppose uh, out of 100, 5 are red color ball and 95 are green color ball. And if you pick up one ball, what is the likelihood that it will be the green color ball? If I pick up, if I pick up randomly one ball, what is likelihood that it will be red color ball and likelihood of green color ball?
5 by 195.
So 5% chances it will be red color, right? So,
Mm.
and green color will be chances है 95%, right? So we can say that the suppose if it is a, let's say 2%, uh, two balls are red and 98 are green. Now we say that probability that it will be the green one. So if it is a red, let's say it's a red color, right? Then what we say that probability, this red color, when we find a red color, probability is less than 0.002. If it is a red color ball, we say that probability of getting a red color ball is less than 0.02. In other sense, P is less than 2%. 2%, we remember 2% very easily, but difficult when you say 0.02. So when we pick up the red color, it is not a green color, right? So the probability, now in this case, suppose instead of two, I will say the two are very, very tall people, very tall people having a, let's say, 150 centimeter height and 3 years age, and rest of the thing are different, right? Two are very tall people and rest of the thing are, let's say, between 65 to, this will make you the thing very clear, right? 65 to 75 are 98 people, right? I unfortunately, may I return to this? Everyone in the meeting should be there. And let me again repeat: two are very tall and having 150 centimeter both, and other 98 are 65 to 75. Now, tell me, if I pick up 150 centimeter guy, what is the probability that it belongs to the group? P is less than 2%, or I can say that probability of event occurring by chance less than 0.02. So this is means that person having 150 centimeter height is least likely to be in this group. Probability that is belongs to the group is less than 2% or less than 0.02. That means it is a significant probability of event occurring by chance. So in this case, if you see that the probability of occurring event by chance, if there is a two, the ball are red ball and the rest of the green ball, the probability of when you get a red ball is much less. It's something unusual. It is not a green. It is not a green. Similarly, a person having 150 centimeter height, it is not in the range. And that's why we say that the probability of occurring by chance is less than 0.05. It is significant. It is not occurring by chance. So P is the probability of occurring by chance. If it is less than 5%, we say that it is significant because of reason. Either it is by chance or it is because of reason. So if you have something to understand more, then you can tell me that again we'll be talking because this P value we need to understand. Any other question? So when I ask you example, if mean is given, if standard deviation is given, you should be find out how much will belong to the area. And probably when I go for Z test next time, there will be 5 types of Z. And I repeat that if Z is more than 2, P is less than 0.05, I will repeat. So before we start a next thing, test of significance, we'll be looking for 5-10 minutes again for this with diagrams. And probably I will talk about histogram also so that you can understand normal curve in a better way. Any question? At least 50 to 60% is the you have understood. So let me finish it off. And I hope that by next time you should install AP Info. If you have any problem in installing AP Info, please let me know. Thank you all.
Thank you, sir.